In this section, we're going to look at the specifics of rivers. Now, a river, the name itself has many different connotations. You may have lots of different pictures in your mind, but basically a river is just channelized flow of water. So this is the drainage basin for the Mississippi River. For the most part, rivers generally flow towards an ocean, a lake, or another river. And they go from high elevation to lower elevation. And that's exactly what happens here along the Mississippi River drainage basin. So that's a new term for you that you may not know. A drainage basin is defined as the entire area drained by a single stream. So you can see in this case, all of the colored parts of this particular map end up feeding into the Mississippi River. That's what we call tributary streams because they contribute to the big river. Now, a couple parts of the rivers that are nice to know. The top of the river, where it starts, is known as the head. The head of the river is generally in mountainous areas and is the highest in elevation. And then the stream flows towards the mouth of the stream. And the mouth is where the stream either flows into the ocean, meets another river, or stops at a lake. Now, what does this mean to look at the drainage basin? So I always like to tell the story. This is Yellowstone National Park. So this is one of the buffalo, or bison, I guess if we want to be a little bit more scientifically accurate. This is one of the bison that live in Yellowstone. And you could tell it's nice and snowy. And there's snow on the buffalo's fur. So let's say that the buffalo lays down and he warms up that snow on his fur and it melts into a drop of water. And that drop of water makes its way to the Yellowstone River, which is what you see here. Now, as it flows down the Yellowstone, it's going to end up going over the Yellowstone waterfalls. This is known as the Grand Canyon of Yellowstone. It's one of those famous shots from the river. So that drop of water is going to flow all the way down the Yellowstone River, which we see right here in this map. So it's going to make its way down the Yellowstone River past Billings and Forsyth and Miles City, all the way down until the Yellowstone River meets the Missouri River. Now, the Missouri River flows from where the Yellowstone meets it all the way down, in this case to the south, through North Dakota and South Dakota and through Nebraska, along the edge of Kansas and into the state of Missouri until it eventually reaches St. Louis. So that little drop of water that melted under the bison gets to flow right past that lovely St. Louis arch. And in St. Louis, it meets its confluence with the Mississippi River. And it makes its way down the Mississippi all the way down into Louisiana until it reaches New Orleans and the Mississippi River Delta. And this is where it joins the Gulf of Mexico. So that one little bitty drop all the way up there on that bison has a really long journey ahead of it as long as it doesn't evaporate or doesn't sink into the ground. Now, what we can see is early on in that trip, the rivers looked a lot different than the end of the trip. So this is what we call a V-shaped valley. These are mountain streams. You usually find these in the headwaters of rivers. They're often in steep gradients. The water flows pretty quickly. They have erosion mostly along the bottom of the river that's known as the bed. And that's why you have such a distinctive V shape with a very steep edge of your valley, is because of that erosion. The stream itself usually is fairly straight if you look at it from the air looking down in map view. But as we progress down the river, things get a little bit flatter right along the river. And you can see now we have a fairly well-developed floodplain, which is that flat area along the river. The valley is a little bit wider. And eventually, when you get to the mouth of the river, it starts wiggling around. We call this a meandering stream. So here's a lovely little diagram for you of a meandering stream. And there's also a picture. And I apologize, I don't actually know what river that is in that image on the top here. But these meandering streams are really interesting. So what you can see here is it's a fairly shallow gradient. It's not very steep. The water doesn't move quite as fast. And in this case, most of the erosion, most of the movement, rather than being along the bed or the bottom of the river like we saw at the head, at the mouth of the river, you mostly get erosion along the banks or the edges of the river. So a meander is just one of these curves. You can see on the outside of the meander, this is what's known as a cut bank. And this is because the water is moving faster around that outside curve. And so it starts eroding into the bank of the river. It's actually a pretty easy term there to remember as the cut bank. On the inside, though, the velocity is a little bit slower. And in that case, you get deposition of sand and gravel. That's called a point bar. And you can see in the image above, the point bars show up really, really nicely. They're mostly sand, and in this case, they're really white compared to the rest of the river and the rest of the geology around it. So you can see those point bars really well. There's some lovely little cartoony things happening. I thought this one was actually really interesting. If you ignore the misspelling of the word weird, I totally stole it from some dude that has a whole bunch of GIFs for his class, and I appreciate it. If you want to remember which side has deposition, remember that's the point bar, but you can fit the letter D for deposition in the middle of that. I thought it was kind of cute. Now, what happens though is sometimes this erosion is not quite a happy thing. I have to admit, I spent far too long researching this particular house and even got help from my Facebook friends. But this is a home up in Cave Creek during a flood in 2010. And what happened was this is usually dry. There's usually not much water at all here in Cave Creek. But during this particular flood, 2010 was a nasty, nasty year for floods in the area. There was a lot more water running through, which means the water was running faster, which means it started eroding. And darned if it didn't erode that cut bank right under this house. Apparently, when the home was built, it was actually 80 feet from the river. And so from the time it was built, I think it was 15 years until this actually happened. So in 15 years, it eroded 80 feet away. And then during this one storm, eroded right under that one room there. I believe I read it was the master bathroom or the master bedroom, but I don't remember on that one. So things get nasty along those banks of a river sometimes. But since the cut bank is constantly eroding and the point bar is constantly depositing, that means the whole river tends to move, and it tends to sort of slither back and forth across that flat area around it that we call the floodplain. And you can see this happening in a Google satellite view from 1986 all the way up until 2000, looks like 13, 14, 15. That's going by pretty quick, but you can see there's some pretty significant changes happening along this river in what is a really short period of time. And this is minus even really big floods. This is just what this river naturally does. And we end up getting a lake left behind when it cuts off one of the meanders. And that lake you can see is U-shaped. That's called an oxbow. Another feature we find in these meandering streams is a natural levee. And you may or may not have heard this term, but if you drive your Chevy to the levee, you want the levee to be dry. If your levee's not dry, it's a flood, and you should probably not be driving to the river in that case. All right, so levees are sort of a high point on the either bank of the stream. These are deposited during flooding when fine sediment gets deposited along the edge of the active channel And what this does is it actually raises up the side of the banks. And oddly enough, this helps control further flooding. So rivers themselves are made to control the flooding, which is sort of interesting. The picture on the bottom right is a river in which the levee has been breached. And you can see that water spilling out and flooding into one of the big areas to the edge of it. And so that floodplain is that nice flat area that's around the river where the river is able to erode the bedrock that's there. But most of that floodplain is just made of sediment that's been deposited during periods of flooding. And so, not that every time it floods, the whole floodplain will be covered, but parts of it will every time the river ends up flooding.